So the modulus function is given as f of x in general equals, say, modulus x. So remember that this modulus makes everything positive. Okay. So if we wanted to sketch this graph, the best way I think of working out how a modulus function looks is sketch the normal function. Say y equals x. Oh, I want that to be a line. Yeah, we sketch a normal function, and then at the bit where we start getting negative, we take our function and we just flip it over the x-axis. So this bit would disappear, and the modulus part to make up for it would be the exact same, but just positive. So this would be y equals modulus of x. And we could do it for loads of functions. So draw it as normal, and then any bits that go under the x-axis do the exact same values of y, but above the x-axis now. Okay. And that's kind of it in terms of sketching it. In terms of solving equations for it, if, say, the simplest case, I've got the modulus of x plus 2 equals 1, equals 3, then we either have, this is the same as saying x plus 2 equals 3, or x plus 2 equals minus 3. Because if either of these were true, the modulus would make it positive. So this would become x equals 1, and then we'd also get x equals minus 5. Okay, so both of those would satisfy the equation. If I had, say, a more complicated one with maybe multiple moduli in, so x plus 3 in here equals, I mean, again, we could have, say, x minus 1. So what we've got for this one, as long as they equal the same numerical value, then it doesn't matter. So either x plus 3 equals x minus 1, or x plus 3 was equal to minus x minus 1. Okay, we could have minus x plus 3 equals x minus 1, but that's the same as this. And we could have that they're both negative, but that would be the same as the top one. Let's make this a 2x. So solving both of these again, we would get that x is equal to 2 for this one. So 2 plus 3 equals 5. No. X plus 3 equals 2x minus 1. That becomes 4. That becomes x, sorry. X equals 4. Or for this one, we'd get x plus 3 equals minus 2x plus 1, which would give 3x equals minus 2, or x equals minus 2 over 3. Okay. So for any modulus, make it so that it's equal, just assuming that the modulus wasn't there, or make it equal as if the modulus was negative. Okay. So let's look at this in a question. So here we've got the modulus of x, which we've already sketched one time. So what I'll do is I'll hopefully shortcut my way to a nice sketch of it. So if I do this, and then rub out some of the parts. Just like that, okay? So this here would be our modulus of x graph. And now the negative modulus of x would be this graph completely flipped over. So it would look like this. But then what we do is we take it and we are translating it up by b according to the question. So if this is going up by b, then I am going to take this and make the intercept, instead of 0, the intercept is now going to be at plus b. So it sort of goes to, say, here. The only thing about this is it should be at 90 degrees here, because we know that y equals x and y equals minus x have are at 45 degrees to the x-axis. Okay, so this would be the 2 marks here, and this would be our b. So part B of this, given that the area in between it is 18 units, find the value of b. Well, if this is 45 degrees, and this is 45 degrees, this must be 90 degrees, which makes all of these other angles 90 degrees as well. So we've got a square here, where if I call the length of the square x, then the overall length, or the height, which is the hypotenuse here, is b. So we get that b squared is equal to 2 lots of x squared. And when and I know that this value is equal to 18. So x squared equals 9. So x is equal to 3. No, sorry, that's a lie. The area is equal to 18. And the area is equal to x times x. Okay, the length of each of the sides. So x squared is equal to 18. So x is equal to root 18. But then for b squared is equal to x squared plus x squared, which is equal to 18 plus 18. So b squared equals 36. B is equal to, and we know it's positive from the question, so b is equal to plus 6. So does anyone have any questions so far about this, what we've done so far? So we've looked at the modulus, we've looked at the odd and even, one-to-one and one-to-many, and so on, and continuity. So are there any questions in the comments? Okay, nice. So the last thing we're going to look at here is going to be the factor and remainder theorem. And again, this is just something that you need to learn, and the main part will come in applying it. So the factor theorem says that if x minus a is a factor of a polynomial f of x, then f of a will equal 0. And then the remainder theorem, of which the factor theorem is basically like a special case, says that if x minus b leaves a remainder of c when f of x is divided by it, then f of b equals c. Okay? So you can find factors by plugging in numbers. So we can find factors to polynomials by trying out numbers. So trying different values of x. Okay. I'm quickly going to run through dividing polynomials just to recap. So what I'm going to do is I'm going to pick a really straightforward one just to demonstrate the idea. So let's say we've got x squared plus 5x plus 6. And I know that x plus 2 is a factor. So first of all, we can double check this. So f of 2 is equal to 2 squared. Sorry, if x plus 2 is a factor, then we put minus 2 in. So minus 2 squared plus 5 lots of minus 2 plus 6 equals 4 minus 10 plus 6, which equals 0. So it must be a factor. Now to divide by it, I do like long division. So I've got x squared plus 5x plus 6. And remember, for long division, what you do is you look at how many lots of the sort of factor or value here we can fit into this. And we start with the highest power of x. So I can fit 1x of this x plus 2, because that will give me x squared. So I put x up the top, and I put into under my long division the value of this bracket multiplied by x. So you get x squared plus 2x, and then I'm going to subtract it. So what you want is you want to get a 0 in all your terms, and then you've got it exactly right. And we end up with plus 3x here. Now you've also got still the plus 6. Now for the 3x, we always just look at the x term. So I need 3 lots of x plus 2, and that's going to be 3x plus 6. And again, when I subtract, I get 0 here and 0 here. Remember that we subtract the whole thing, so the minus applies to both terms. So if we know that x squared plus 5x plus 6 divided by x plus 2 is equal to x plus 3, then we can also say x squared plus 5x plus 6 equals x plus 2, x plus 3. So sometimes it's easy to factorize it, and sometimes it's not. And when it's not, polynomial division is something that's really useful.
I hope you enjoyed the video. If you did, be sure to click down here to like, subscribe, and share with a friend. If you'd like to access the full online course, including the notes pages we were making, there's a link in our description below. Thank you for watching, and good luck with your revision.